Hi friends, here is a very interesting problem. We have to prove sum of cubes of three successive integers is divisible by 9. Right. We know a plus b cube is a cube plus 3a square b plus 3ab square plus b cube. Here what we write, let's take the numbers as n plus 1, n plus 2 and let's cube all three of them and add them. Simple arithmetic manipulation. Let's see if we are getting 9 as 5. Right. So n plus b cube is a cube plus 3a square b plus 3ab square plus b cube. What is n plus 1 cube? N plus 1 cube is n cube plus 3a square b, that is 3n square, plus 3ab square, that is 3n times 1 square, which is still 3n, plus b cube, which is 1. Similarly, what is n plus 2 cube? This is cube. Sorry for the typo. This is cube. N plus 2 cube is a cube, again n cube plus 6n square, 6n square, because 3a square b, 3n square into 2, which is 6n square, plus 3ab square, plus 3n into 4, which is 12n, plus b cube, which is 2 cube, which is 8. N cube is n cube. Let us sum all three of this. You want the sum of all three, right? if we get this is divisible with the sum of all three is divisible by 9, that is what we have to prove. Let us sum all of this and see if 9 is a factor of this one. If we can take 9 common, let's see, n cube, 3n cube plus 9n square plus 15n plus 9. Here this one n, this is 9 and this is 9 square. So these two parts is anyway divisible by 9. We are worried about 3n cube plus 15n. Right, we are worried about these two terms only. If we somehow prove that 9 is a factor of 3n cube plus 15n, then we are sorted. Okay, let's take this 3n cube plus 15n and write it as, and take 3n common, 3n times n square plus 5. Right, so now if n can be any number, right? N can be any number. N can be 1, 2, 3, 4, 5, 6, 7, 8, whatever. Right. Now, any number when divided by 3, any number, whatever number you take, when divided by 3, it will either leave a remainder 0 or remainder 1 or remainder 2. Remainder 3 is not possible. If remainder 3, then that means either remainder should have been 0. For example, 6 when divided by 3 becomes, it leaves remainder 0. Right? It is 3 plus 3, so remainder will be 0. Right? It cannot leave remainder 3. Remainder 3 means it is actually divisible by 3. So that means it is the remainder 3 means actually remainder 0. So any number if you take, any number when you divide by 3, it will either leave a remainder 0, so it's a multiple of 3, or remainder 1 or remainder 2. So n can be 3 times some constants or 3 some factor remainder 1, 3 into k plus 1, or remainder 2. N can be 3 some k times 3 plus 2, some k times 3 plus 1. N can be in this form only. Right. When n is of this form 3k, right, then this 3n is obviously, will be of the form, or this 3n, when n is 3k, 3n will automatically be a multiple of 9, right? Because there are two 3's, one 3 here and one 3 in the n. So this becomes, the 3n becomes 9k, which is obviously a multiple of n, multiple of 3. So we are sorted when n is 3k, right? When n is 3k, this number is actually a multiple of 9. So we are sorted here. When n is 3k plus 1, right, when n is 3k plus 1, and we have only three options, n is 3k plus 1, then let's see, and what happens to this n square plus 5. 3k plus 1 whole square is 9k square plus 6k plus 1. Right. 3k plus 1 whole square, a plus b whole square, a square plus 2ab plus b square. Right. Now 3k plus 1 whole square, that means n square plus 5. This 1 plus 5 becomes 9k square plus 6k plus 1 plus 5 becomes plus 6. Now here, this one if you see, this is clearly divisible by 3. So because here 9, here 6, here 6, that means this is a multiple of 3. So n square plus 5 is actually a multiple of 5, multiple of 3. So one more 3 outside. So that means this entire expression is a multiple of 9. 1 3 outside, 1 3 in n square plus 5. Right. So that means this entire expression is actually divisible by 9. Right. We are concerned about this expression only because in the overall sum, other two are anyway divisible by 9. Right. Now, in the case of n plus 2, n can be either n plus 1, n or 3, n can be either 3k or 3k plus 1 or 3k plus 2. Right. When n is of the other form, of the third form, 3k plus 2, for example, n is something like 5. N is something like 5. 3 plus 3k plus 2, 3 into 2, n is something like 5. So, then what is happening to n square plus 5? N square plus 5 is 3k plus 2 whole square plus 5, which is 9k square plus 12k, right? 2ab, 2 times 3 times 2, right? 12k plus 2 square, which is 4 plus 5, 9. Here also, this is also a multiple of 3 because 3 and 9 is a multiple of 3, 12 is a multiple of 3, 9 is also a multiple of 3. So this is also divisible by 3. That means the inside part, for example, 5 square plus 5, we are saying inside part is 30. Right, inside part has got one 3 and outside part has got another 3. So whatever it is, when n outside also one 3 is there, inside also one 3 is there. So the product of it is definitely a multiple of 9. So 3n cube plus 15n, 3n cube plus 15n is always a multiple of 9. Right. So that means the overall sum is multiple of 9. That is what we wanted to do. Right. Sum of cubes of three successive integers is always divisible by 9. That's why. Right, guys. Thank you.